All right, guys, let's look at the second part of our notes now. I know some of you have already started on that second part of the homework, but let's just kind of go over a few things here. So one of the things we're going to be looking at in this part is, can we match data with a function, and can we find a constant? So that's something we should be able to do. That's like this problem here. We're given some function, we're given a bunch of points that the function passes through. So we should, by using these points in this function, be able to find the value of c. Another thing we want to be able to do is to look at graphs and word problems and be able to compare them and make sense of them. The third thing is we want to be able to find and evaluate composite functions. Composite functions look like this, which is the same thing as this. So we're going to be looking at how to do that, the f of g of x type of thing. And then the last thing is stating whether a function is even or odd. Knowing whether a function is even or odd can help us to determine the way it looks. So that's why we learn about that. So let's look at this first problem. It says, given that f of x is equal to c times the square root of the absolute value of x, and it contains the following points, find the value of c. So we know that this function, this square root function, has to contain all of these points. Well, in a function, f of x, we have to remember that just equals y. So here's really what our function is. We can take any one of those points and plug it in and figure out what our c value is. So I'm just going to take the very first one. Here's x, here's y. I'm going to plug in -4 for y. C, I don't know. Square root of absolute value of x. So that's going to give me -4 equals, the absolute value of -4 is 4, so I'm going to have c times the square root of 4. Square root of 4 is 2, so we have 2c equals -4. Divide by 2, and c equals -2. So we know the value of c, and that's what they asked us to find, and so that would be the function. Now, let's say that I'm taking a quiz or a test, and I just want to make sure that's right. Remember some things we can do on our graphing calculator to check. So now I know my function is y equals c, which was -2. The square root, I can go under math, over to num for absolute value. Whoops, picked the wrong one. Let me start over. Math, num, absolute value of x. Okay, so now what I'm going to do is I'm going to get out of there, and I'm going to just graph that. So here's the way it looks. And now I'm going to look at my table of values, and I'm going to make sure that these points pass through it. So I look at my table of values. I've got -4, -4. I've got -1, -2. I've got 0, 0, so I know that that's correct. Okay? All right, let's come over here now. This is the word problem and the graph component I was talking about a minute ago. It says, Sam was at his friend's house. He started walking home. He realized he left his phone at his friend's house, so he ran back, grabbed the phone, and ran home. He had to stop to wait for traffic, then he continued walking home. Which graph is the best function to describe Sam's distance from home as time goes on? So we want to look at these graphs. The x-axis, it says, is our time. The y-axis is the distance from home. So time, distance from home. Time, distance from home. All right, so which one of these three do you think would be best? Olivia? A? How'd you know that? Exactly, yeah. It couldn't be these two, could it? Because the distance from home is starting off at 0, and he's not starting off at home. So it makes perfect sense. He's walking, so he's getting closer to his house. Then he runs, so see how this is steeper? And then he grabs the phone, so he's going to be at his friend's house still. Then he's going to run home, and so that's really steep there. Then he got stopped by the traffic, and then he started walking home. So that's not quite as steep as when he was running. Okay? So now it says to write a word problem to describe the situation in letter C. Okay? So kind of think about that, and then I want you guys to tell me what you can't come up with. Can anybody just tell me what they're thinking and I'll write it for you? Natalie, you got anything going? Go ahead and try it. What do you think?
All right. So, Jim went on the morning run, and then he stopped at a park bench because he was tired. And then on his way back, he got coffee, so that's like the second stop.
Mm-hmm.
And then he walked home.
Great. I like it. Walked home, got coffee, walked home. That sounds like my kind of morning. That I would only want to run just that really short distance. He's not running very long, takes a little break, walks, gets some coffee. Sounds like a nice morning. Walks home. All right, very good. That would be a good example. So you can see how that would all work out just perfectly. Anytime that his distance is not changing, that means that he is not moving. And so that's why she had to say he stopped to rest. And then here he's getting coffee, so he's just standing there waiting at Starbucks or wherever he is. And then he walks back home, so he's getting closer and closer to home. All right, very good. Yep. Right. What? Oh, walked, I should say towards home. Yeah, walk towards, yeah, maybe the coffee place was on his way home, yeah. Yeah, he couldn't have been walking, he's walking in that general direction though. And the reason we do have to say that, like he can't be really, we would have to say that it's like the coffee shop's on his way home because he's getting closer to home. So, yeah, good point, thanks. All right, composite functions. F dot G means the same thing as f of g of x. G dot F means the same thing as g of f of x. So we're going to find those for this problem, and then we're going to state what's the domain of each composite function. And then we want to answer, are the two composite functions equal? So here's f of x and here's g of x. So we want to find f of g of x. I like to do this one step at a time. So we're going to have f of, and now I'm going to look and see what is g of x. Okay, here's g of x. So this is what I'm doing, is this problem here. So now in my f function, instead of using x, wherever I have an x in this f of x function, I have to replace that x with x squared plus 1. So this would be what f of g of x is. I know that the denominator cannot equal 0. Is there any x that's going to make the denominator equal 0? No, because if I square something, what happens to it? It turns positive, and if I add 1, it's just more positive. So that means that our domain on this one is negative infinity to infinity. All right, now let's go in the other direction. G of f of x. So I'm going to replace my f of x. What is f of x? Okay, that's 2 over x. So now in my g function, wherever I have an x, my x is no longer going to be an x. Now it's going to be a 2 over x. So right here, this is getting replaced with 2 over x. And right here, this is getting replaced with 2 over x. So I'm going to have 2 over x squared plus 1. So what is 2 over x squared? 4 over x squared, right? I got to square that and square that. All right, so what's the domain of this one now? Negative infinity up to 0, union 0 to infinity. So since their domains are not even the same, I know that the functions themselves are not the same. You know, a lot of times we can simplify something to see if functions are the same, but this is something you might not have thought of. You could also put things in your calculator to see whether or not they're the same thing. See, look, if I put this one in and then I put this in, and I'm going to make this one bold so I can tell the difference. You guys don't have to do that on the newer calculators. But look, if I look at this now with the Zoom 6, here's the way they look. Here's my first function, and here's my second function. And see, I can see they're definitely not the same functions. But I don't have to do that to figure it out. All right. Any questions on that? Okay, let's look down at the end here at even and odd functions. So a function is even if f of negative x is the same thing as f of x. So that's saying if I replace x with negative x and get the same thing, it's an even function. An odd function means if I replace x with negative x, I get the exact opposite function. So odd functions are always symmetric with respect to the origin, and even functions are always symmetric with respect to the y-axis. So let's look at some of these. Even, y equals x squared would be an even function. See how it's symmetric with respect to the y-axis? Odd, y equals x cubed. Looks like this. See how it's symmetric with respect to the origin? Okay? All right, so those are the two rules. So if I know what a function just looks like, I can tell whether it's even, odd, or neither. But sometimes it's not so easy. So I'm going to do f of negative x on this one. Here's an x, replace with negative x. Here's an x, replace with negative x. So now, evaluating this. If I have a negative x squared, that turns into a positive. I have another negative x squared, that's going to turn into a positive. And so f of negative x is exactly the same thing as what I started with. So what does that tell me about it? It must be even, right? So if I were to graph this on my calculator, I would see a function that was symmetric with respect to the y-axis. All right, what about this one? F of negative x. I replace the x with a negative x. What's the fifth root of a negative going to be? Positive or negative? Negative. So this is going to be negative, the fifth root of x. So that is the exact opposite of what I started with. So this would be an odd function. This would be a cool one to look at because I don't think a lot of people know how to put in the fifth root of x. Do you guys know where to go to find the fifth root of x? All right, here's where you have to go. If I want to type this in, I have to go under math, and I have to go down here to number 5. See how it's the xth root? And now it asks me, what do you want your root to be? And I say the fifth root. And now I'm going to do a zoom 6. Here's the way the fifth root of x looks. See how that's symmetric with respect to the origin? So it's an odd function. Okay? All right, last one. F of negative x. I'm going to plug in, for x, I'm going to plug in a negative x. And then it's got to get squared. What's going to happen if something gets squared? It's always going to be what? Positive. Now, I want you to think about this too, what this actually means. The cosine of positive x means we're going in this direction, so like the cosine of positive 30. If I did negative 30, all that means is I would be going in this direction. Are those answers going to be the same for the cosine? 30 degrees. This would be 1, this would be negative 1, this would be radical 3, and this would be 2. So the cosine of positive 30 is radical 3 over 2. What's the cosine of negative 30? They're the same thing, aren't they? So therefore I know that this is actually going to be the same exact function here and here. The result's the same. So this is going to be an even function. All right? Any questions over anything? Okay, good job. You can finish up the homework.